And when I was 9 years old, I had a dream to create my own computer games. And so I've learned to code. As you might imagine, since then I didn't try any games whatsoever, but somehow I ended up battling and taming the complexities of enterprise software. Currently, I serve as the chief architect for a company called Internovus. The peculiar thing about Internovus is that we've been using domain-driven design since the day the company was founded. And I'm here today to share with you our DDD journey. In the first part of this presentation, I'll walk you through the various systems from our domain and how we've implemented them. Of course, I won't be able to cover everything we've done. Therefore, I'll concentrate on 5 bounded contexts that demonstrate the different approaches to DDD that we've tried and the results that we've achieved. In the second part, I will use those 5 stories to share some practical advice on domain-driven design, event sourcing, microservices, and software architecture in general. So let's get started. About 7 years ago, I got a phone call from a friend. He said that he was starting a new company. The business was not going to be simple, but if I joined him, technically, I could do whatever I wanted. And since back then I had a pretty boring job, I've agreed just like that. Let's see what I've got myself into. Say you're producing a product or a service. Internovus allows you to outsource all your marketing-related chores. We'll come up with the best marketing strategy for a product. Our copywriters and graphic designers will produce tons of creative materials, such as banners and landing pages, that we will use to run campaigns to promote your product. All the leads generated by these campaigns are going to be handled by our own sales agents who will make the calls and sell your products. And most importantly, this whole process provides many opportunities for optimization. And that's exactly what our analysis department is going to do. They're going to analyze all this data to make sure that you are getting the biggest bang for your buck, be it by pinpointing the most successful campaigns, the most effective creatives, or by identifying the most promising leads for the agents to work on. And that's the system that I signed up to build. Since we were a self-funded company, we had to get rolling as fast as possible. So we started by implementing the first third of our value chain. We had to provide a way for media buyers to manage contracts with various publishers, a catalog for our designers to manage their creatives, and of course a campaign management solution to run advertising campaigns, which meant not only a management system, but an ad serving and hosting solution as well. I don't know about you, but initially these business domains sounded terribly complex to me. Fortunately, not long before we started working, I read a book called Domain-Driven Design, Tackling Complexity in the Heart of Software. Who read this book, by the way? Okay. And who knows what domain-driven design is? Awesome. Great. So, as you might know, this was not an easy book to read. But luckily for me, I felt that I've got a really strong grasp of domain-driven design just by reading the first 4 chapters. Guess how the system was initially designed? Its architectural style could be neatly summarized as aggregates everywhere. Creative, agency, advertiser, publisher, each and every noun in the requirements was proclaimed as an aggregate. And of course, all those so-called aggregates resided in a huge, lone bounded context. Yeah, exactly the same monolith that everyone warns you about nowadays. And of course, those were no aggregates at all, just an anemic domain model. They didn't provide any transactional boundaries, and they had very little behavior in them. All the behavior was here, in a big, fat service layer. Frankly, this design is no work of art, right? It's like by-the-book example of what domain-driven design is not and how not to implement it. However, things looked quite different from the business standpoint. From their point of view, this project was considered a huge success. Despite the imperfect architecture and despite our very unique approach to QA, we delivered working software in a very aggressive time to market. How did we do it? How did it happen? And the answer is simple: ubiquitous language. We somehow managed to come up with a robust, ubiquitous language. None of us had any prior experience in online marketing, but nevertheless, we could hold a conversation with domain experts. We understood them, they understood us, and to our astonishment, domain experts turned out to be really nice people. They really enjoyed and appreciated the fact that we were willing to learn from them and their experience. And this smooth communication allowed us to grasp the business domain very quickly and to implement its business logic. And again, yes, it was a very big, scary monolith, but for two developers in a garage, it was just good enough. Again, working software in a very aggressive time to market. And this diagram sums up our understanding of domain-driven design at this stage: ubiquitous language and an anemic domain model in a monolithic bounded context. As some time passed, leads started flowing in, and we were in a rush. Our sales agents needed a robust CRM, a customer relations management system, to work with. The CRM had to aggregate all incoming leads, group them based on their target markets, brands, and different parameters, and distribute those leads across multiple sales desks around the globe. Also, the system had to integrate with our clients' internal systems, both to complement our leads with additional information and to notify the clients about the changes in the leads' life cycles. And of course, the CRM had to provide as many optimization opportunities as possible, such as ability to make sure that agents are working on the most promising leads, to assign leads to agents based on their qualifications and past performance, and to allow a very flexible solution for calculating agents' commissions. And since all these requirements didn't quite fit any existing off-the-shelf product, we decided to roll out our own CRM system. Our initial implementation approach was the good old DDD Lite. We'll call each noun an aggregate and shoehorn them into the same big monolithic bounded context. This time, however, something felt wrong right from the start. We noticed that all too often we were adding awkward prefixes to aggregates names, like CRM lead and marketing lead, marketing campaign and CRM campaign. And interestingly, we never used those prefixes in conversations with domain experts. Somehow they always understood the meaning from the context. And then I recalled that there was a chapter with something about context in that big blue book. So I went back, and this time I read the big blue book cover to cover. I learned that bounded contexts solve exactly the same issue that we had experienced. They protect consistency of the language. Also, by that time, von Werner's book came out. I read it, and I finally understood that aggregates aren't just data structures, but they play a much more important role by protecting consistency of the data. So we took a few steps back and redesigned the CRM solution to reflect these revelations. First of all, we divided our monolith into two distinct bounded contexts: marketing and CRM. We didn't go crazy with microservices here or anything like that. We just did the bare minimum to protect the ubiquitous language. However, in this new bounded context, we were not going to repeat the same mistakes we did in the marketing context. No more anemic domain models. Here, we would implement a real domain model with real by-the-book aggregates. In particular, we promise that each transaction will affect only one instance of an aggregate. Instead of an ORM, the aggregate itself will define the transactional scope, and the service layer will go on a very strict diet, and all the business logic will be moved into its corresponding aggregates. And we were so enthusiastic about doing things the right way, but soon enough, it became apparent that modeling a proper domain model is damn hard. Relative to marketing context, suddenly everything took way more time. it was almost impossible to get the transactional boundaries right the first time. We had to evaluate at least a few models, test them out, only then to figure out that the one we hadn't thought about before was the correct one. So the price of doing things the right way was very high for us, a lot of time. And sooner than later, it became obvious to everyone we would not meet the deadlines. And then our management decided to help us. They offloaded implementation of some of the requirements to DBAs. Yeah, store procedures. And this one decision did so much damage. Not because SQL is not the best language for describing business logic, no. The real issue was a bit more subtle. This situation produced an implicit bounded context with its boundary dissecting one of our most complex business entities, the lead. The result was two teams working on the same business component, implementing closely related features with minimal interaction between them. And of course, there was no ubiquitous language. Literally, each team had its own vocabulary to describe the business domain and its rules. Conway's law kicked our asses. The models were inconsistent, there was no shared understanding, knowledge was duplicated, the same business rules implemented twice here and there, and rest assured, when the logic had to change, the implementations went out of sync just like that. A complete nightmare. The project wasn't delivered anywhere near on time and was full of bugs, nasty production issues that had flown under the radar for years, corrupting our most precious asset, our data. And the only solution for fixing this mess was to completely throw away the old code and to rewrite the lead aggregate from scratch, this time in proper boundaries, which we did a couple of years later. It wasn't easy, but the mess was so bad that there was no other way around it. And to sum it up, at this stage, our understanding of domain-driven design looked like this. Ubiquitous language, bounded context to protect the integrity of the language, and instead of an anemic domain model everywhere, a proper domain model everywhere. Of course, a crucial part of DDD is missing here. Subdomains, their types, and their effects on implementation strategies. And initially, we wanted to do the best job possible, but we ended up wasting time and effort on building domain models, mostly for supporting subdomains. As Eric Evans put it, not all of a large system will be well designed. And we learned it the hard way and wanted to use the acquired knowledge in our next project, Event Crunchers. After the CRM was rolled out, we've noticed that there was an implicit domain spread across marketing and CRM. Whenever the process of handling incoming customer events was modified, we had to introduce changes both in marketing and CRM. And since conceptually this process didn't belong to any of them, we've decided to extract this logic into its own bounded context, Event Crunchers. And since we didn't make any money out of the way we move data around, and we couldn't use an off-the-shelf solution, it looked pretty much like a vanilla supporting subdomain. So this time we decided as such. Nothing fancy, just some simple ETL-like transaction scripts. And this solution worked well for a while. As our business evolved, we implemented more and more features right here. BI people asked for some flags to mark new contacts and another flag to mark new contact for a specific brand, etc., etc. And eventually, those simple flags have evolved into real business logic with complex rules and invariants. Guess what happens when you implement a complex business logic as an ETL transaction script? This happens. What started out as an ETL script grew up to be a fully fledged core domain. And since we didn't adapt our implementation strategy, we ended up with a huge ball of mud. Each modification to this code base became more and more expensive, quality went downhill, and at some point we were forced to rethink our implementation. We did it a year later. By that time, the business logic grew up to be so complex it could only be tackled with event sourcing. So we refactored this code into an event source domain model with other bounded contexts subscribing to its events. And we also had a very similar experience in another project. One day, sales desk managers had asked us to automate a simple yet tedious procedure that until then they had been doing manually, calculating commissions for sales agents. Again, it started pretty simple. Once a month, just calculate a percentage of each agent's sales and send the payment reports to the managers. As before, we contemplated whether or not this was our core business domain. And the answer was no. We are not inventing anything new here. We are not making money out of this process. And if there was an option to buy an existing solution, we definitely would. So not core, not generic, but a typical supporting subdomain. Therefore, again, we didn't go crazy over its design. Active record objects orchestrated by a big service layer. Once this process became automated, boy, did everyone in our company become creative about it. Our analysts wanted to optimize the heck out of it. So they said, let's try out different percentages, and what if we make the percentages a function of a price, or maybe both a price and a number of sales, and maybe additional business criteria, etc., etc. And guess when this implementation has broke down? And it did break down. Again, the code base became a ball of mud. Adding new features turned to be very expensive. Bugs started to appear, and when you are dealing directly with money, even a small bug can have some very big outcomes. As with crunchers, at some point, we couldn't bear it anymore. We had to completely throw away the old code and rewrite it from ground up, this time as an event-sourced domain model. Now, let's see what happened here. Just as in the case of event crunchers, the business domain was initially categorized as a supporting one. But as the system evolved, it gradually mutated into a core domain. We found ways of making money out of these processes. However, there is a striking difference between these two bounded contexts. For the bonuses, we had a ubiquitous language. And even though the initial implementation was based on active records, we could still have a ubiquitous language. But as the complexity grew, the language got more and more complicated as well. It could no longer be modeled using active records. And this allowed us to notice the need for a change in the implementation strategy much earlier than the case of crunchers. And we saved a lot of time here by not trying to fit a square peg in a round hole, thanks to the ubiquitous language. And that's what our vision of DDD looked like at this point. Pretty much a classic one, nothing special. The fifth bounded context that I wanted to talk about is the marketing hub. One day, our management was looking for a profitable new vertical. So they pondered, why couldn't we use our ability to generate massive amounts of leads and sell them to smaller clients, ones we didn't work with before? And they decided to give it a try. This project was called Marketing Hub. Since this domain was defined as a new profit opportunity by the management, it was clearly a core business domain. Therefore, design-wise, we pulled out the heavy artillery here. Event source domain model, CQRS, and back then, a new buzzword started gaining lots of traction, microservices. So we decided to give it a try. That's what our solution looked like. Small services, each had its own database, both synchronous and asynchronous communication between them. On paper, we expected it to be a work of art. In practice, as always, not so fast. We naively approached microservices, thinking that the smaller the service, the better. So we drew boundaries around the aggregates. In DDD lingo, each aggregate became a bounded context on its own. And again, initially it looked great. It allowed us to implement each service according to its specific needs. Only one would be used in event sourcing, and the rest would be state-based aggregates. And all of them could be maintained and evolved independently. However, as the system grew, those services became more and more chatty. Almost each of them needed data from all other services to complete some of its operations. The result? What was intended to be a decoupled system ended up being a distributed monolith, an absolute nightmare to maintain. And there was another issue we had with this architecture. We had used the most complex patterns for modeling the business logic, event sourcing, and domain model. We carefully crafted all those microservices, but it all was in vain. Behind this complex architecture stood a very simple business logic. So simple, it could have been implemented using active records. Despite the fact that it was considered a core domain by the business, it had no technical complexity in it. Turned out the business was looking to make money not by clever algorithms, but by leveraging our existing relationships with other companies. And when technical and business complexities differ greatly, it is called an accidental complexity. And this architecture ended up being exactly that, accidental complexity. The system was over-engineered. Those are the 5 bounded contexts that I wanted to tell you about: marketing, CRM, crunchers, bonuses, and marketing hub. And again, it may sound like we're a bunch of losers who cannot get anything done right, but I wanted to show you the bounded contexts, the systems that we learned from. So now let's see what we learned from this experience. First and foremost, the ubiquitous language. I believe that ubiquitous language is the most important part of domain-driven design. This is the core domain of DDD. The ability to speak the same language with domain experts proved to be indispensable for us. It turned out to be a much more effective way to share knowledge than documents, tests, and even Jira. And more than that, the ability to hold a conversation with domain experts for us was a major predictor of project success. Like in our marketing context, when we just started, our implementation was far from perfect, but the robust ubiquitous language compensated for the architectural shortcomings, and we were able to deliver the project's goals. In the CRM context, we screwed it up. Unintentionally, we had 2 languages describing the same business domain. This led to lots of problems, and even though we strived to have a proper design here, because of the communication issues, we ended up with a huge mess. The Event Crunchers project started as a supporting subdomain, so we didn't invest in the ubiquitous language. When the complexity started growing, we regretted this decision big time. Even though we had to redesign the project, it would have taken us much less time had we initially started with the ubiquitous language, like we did in the bonuses project. Here, the business logic became orders of magnitude more complex, but the ubiquitous language allowed us to notice the need for a change in the implementation strategy much earlier. And speaking of supporting subdomains, it doesn't really matter what kind of business domain you are working on, core, supporting, or even generic. Our take on it right now is that ubiquitous language is not optional for any of them. We've also learned to invest in the ubiquitous language early on. From our experience in the CRM context, it is practically impossible to fix a language if it has been spoken for a while in a company. We were able to fix the implementation here. It wasn't easy, but eventually we did it. But that's not the case for the ubiquitous language. To this day, some people still use the conflicting terms that were defined in the initial implementation. Also, if you take care of the ubiquitous language early enough, it is very cheap. Many have the impression that it will be expensive to allocate domain experts' time for interaction with IT people. Not true, at least in our case. Our domain experts were sick and tired of software engineers trying to act as if they know better how to solve problems in domains they have absolutely no experience in. And that's why they were so cooperative and willing to help. Next, domain types. We all know that according to domain-driven design, there are three types of business domains. Core domains, the stuff that you do differently from your competitors to gain competitive advantage. Supporting domains, the stuff you do differently from others, but it doesn't provide any competitive edge. And generic domains, the stuff that everyone is doing in the same way. It's a common practice to use this categorization to drive design decisions. For the core domains, use the heavier artillery, domain model or event sourcing. Supporting domains can be implemented with some rapid application development framework, and generic domains, in most cases, are cheaper to buy than to implement yourself. However, for us, there was a problem with this model. Companies, and especially startups like ours, tend to change and reinvent themselves over time. Businesses evolve, new profit opportunities are discovered, others neglected, and sometimes unexpected opportunities pop up. As a result, business domains types change accordingly. Speaking of our company, I think I've experienced almost all the possible combinations of such changes. For example, event crunchers and bonuses. Both of them started as supporting domains, but once we discovered ways of making money out of these processes, they became our core business domains. In, in the marketing context, we implemented our own creative catalog. Nothing special or complex about it. However, a few years later, an open source project came out, and it offered exactly the same functionality that we had, and even a bit more features. So we threw out our implementation and replaced it with this open source project. And what happened here? Our supporting domain became a generic one. In the CRM context, we had an algorithm that evaluated and identified the most promising leads. We refined it over time, tried different implementations, but eventually we replaced it with a fully managed machine learning model running on AWS. A core domain became a generic domain. We've also seen our marketing hub context. What started as a core domain ended up being a supporting one, since the competitive edge resided in a completely different dimension. And we have quite a few examples in our industry of companies that turned generic and supporting domains into their core business. For example, Amazon and their AWS cloud. Now, once this kind of change happens, your design should evolve accordingly. Failing to do so in time will lead to lots of accidental complexities. Hence, instead of making design decisions based on domain types, now we prefer to reverse this relationship. For each domain, we design its implementation strategy first. No gold plating here, the simplest design that will do the job. And from this design, we deduce the domain's type. And the first benefit of this approach is less waste. The implementation is driven by the requirements at hand. It's not going to be over-engineered as it happened for us in the Marketing Hub project, and it's not going to be under-engineered as we did in the bonuses context. Second, reversing this relationship creates a dialogue between you and the business. And sometimes business people need you as much as you need them, because if they think that something is a core business, but you can implement it in a day, then probably some questions should be asked about this core business. On the other hand, what if a domain is considered as a supporting one by the business, but it can only be implemented with a domain model or event sourcing? And that's where things get interesting. There are two options. First, maybe the business people got over creative with the requirements and ended up with accidental business complexity. It happens. In such case, the requirements can and should be simplified. Second, it might be that the business can employ this domain to gain an additional competitive edge, as it happened with our bonuses module. In such a case, you are helping the business to identify new profit sources much faster. And by the way, designing the implementation strategy is pretty simple. We have a couple of very simple heuristics to streamline this decision-making process. The most important question you have to answer here is, how should the business logic be modeled in code? And we have four options, four patterns: transaction script, active record, domain model, and an event-sourced domain model. You can decide which of these patterns you should use by answering a few questions. First, does the domain in question deal with money directly, require deep analytics, or require an audit log by law? If the answer is yes, use the event-sourced domain model. Second, how complex is the business logic? Is it more complex than some input validations? Does it have complex business rules and invariants? If it does, use the domain model. Third, if on the other hand, the business logic is simple, then how complex are the data structures? If you've got some complicated object trees, go with an active record. Lastly, if answers to all those questions were negative, use a simple transaction script. And once you've decided which of these patterns to use, it's a trivial job to map a suitable architectural pattern. In most cases, event sourcing requires CQRS. Domain model requires hexagonal architecture. Use layered architecture for active records, and for transaction script, in many cases, you can even do away without layers. Now, let's say you've chosen an implementation strategy, but over time, it started breaking under its own weight. For example, you've been using the active record pattern, but maintaining and modifying the business logic became painful. And this pain is a very important signal. Use it. It means that the domain has evolved. It very well might be the time to go back and rethink its implementation strategy. If the type has changed, talk with the domain experts to understand the business context. If you need to redesign the implementation to meet the new business realities, don't be afraid of such a change. Because once the decision of how to model the business logic is made consciously, and and you're aware of all the possible options, it becomes much easier to react to such a change and to refactor the implementation to a more elaborate pattern. And finally, let's talk about bounded contexts. At Internovus, we've tried quite a few strategies for decomposing a system into bounded contexts. First, we tried linguistic boundaries. We split our initial monolith into marketing and CRM contexts to protect our ubiquitous language. Next, we tried domain-based boundaries, and most of our business domains were implemented in their own bounded contexts. For example, crunchers and bonuses. We also tried dedicating a bounded context for a single aggregate. This approach failed miserably in the Marketing Hub project, but it did work in others. And finally, I also shown you how we dissected an aggregate into two different bounded contexts. This strategy can be called suicidal boundaries. Don't ever try this at home. But seriously, as this paper says, correct boundaries are important for a peaceful coexistence of systems and teams in our case. So after trying out many ways of doing it, I want to show you the strategy for setting the boundaries that we're using right now. As Udi Dahan said, finding boundaries is really hard. There is no flowchart for that. And since there is no flowchart, the only way of finding the right boundaries is by making some trial and error work yourself. Which means, by definition, there will be mistakes. There is no way around it. So let's acknowledge this and only make mistakes that are easy to fix and try to avoid doing the fatal ones. And in our experience, it is much cheaper and safer to extract a bounded context out of a bigger one than to start with bounded contexts that are too small and to merge them later. Therefore, nowadays we prefer to start with bigger contexts and decompose them later as more knowledge is acquired about the business. How big should the initial boundaries be? And the heuristic that works best for us is the less you know about the business domain, the wider the initial boundaries are. So for more complex domains, start with bigger boundaries. But for simpler ones, like supporting domains, you can start decomposing a bit earlier. And when we've tried to decompose to fine-grained bounded context early on, as in the case of Marketing Hub, we ended up with a distributed monolith. On the contrary, the marketing context started up as a pretty big monolith, but was decomposed later on. We extracted campaigns, publisher, creative catalog events, all into separate bounded contexts. And again, it is evident even here. The simpler the domain is, the more narrow are its boundaries. Hence, our policy is, again, start with bigger boundaries and decompose, if needed, as you gain domain knowledge. And time to sum it all up. Ubiquitous language is not optional. Domain types change. Embrace these changes. Use them to make your design stronger. Learn the ins and outs of the 4 patterns of modeling business logic. And finally, start with bigger boundaries and divide as you gain more domain knowledge. And this is our current approach to implementing domain-driven design. We always start with the ubiquitous language. To protect the language, our initial decomposition strategy adheres to the linguistic boundaries of the language. For each domain, we decide how it will be implemented by following the simple heuristics I've shown you earlier. And from this design, we deduce the types of business domains at play and verify them with the business. And finally, as more domain knowledge is acquired, we decompose the bounded context even further into more fine-grained microservices. But again, only if there is a good reason for decomposing them. And if we compare our vision of DDD now to the one we started with, I would say that the main difference is we went from aggregates everywhere to ubiquitous language everywhere. And that's it. Thank you.